Greetings students, in this session you will be taught how to assemble circuits of a battery charger and inverter.
Objectives. You will be able to use it at the end of this exercise. Draw the circuit diagram as per specification. Assemble the battery charging circuit wired on PCB. Do the testing of the circuit wired on PCB. Construct the inverter for the given specification. Do the load testing for the inverter. Let us take a look at the tools and instruments required for assembling circuits of battery charger and inverter. Trainees Toolkit 1 set. Soldering iron 35 watt 250 volt 1. Desoldering gun 65 watt 250 volt 1. Star screwdriver set 1. Ammeter 0 to 10 ampere MC 1. Voltmeter 0 to 50 volt MC 1. Digital multimeter 31 by 2 digits 1. Equipments or machinery. Auto transformer 0 to 270 volt 5 ampere 1. Step down transformer 240 by 40 volt 300 VA 1. Charger transformer with center tapping 6 volt 0 6 volt 500 milliampere 1. Sealed maintenance free battery 6 volt by 120 Ah 1. Relays double pole 3. Materials or components. PCB 115 general purpose. 2. Push button switches 2. Toggle switches 250 volt by 6 ampere 2. Diodes 1N4002 4. Diodes for bridge 1N112 4. Capacitors 250 microfarad by 12 volt 1. Resistors 10 ohm 1 watt 1. Pot 1.5 ohms per 10 watt 1. Low voltage lamp 6.3 volt 1. Fuse 250 milliampere 3. Neon lamp 1. Buzzer 250 volt 1. Soldering flux and 60 by 40 solder as required. Diode IN5402 3. LED red and green 1. Transistor 2N3055 1. Resistor 2.2 ohm 22 ohm 50 ohm 1 number each 1K 1 watt 2. Electrolytic capacitors 1000 microfarad by 25 volt 10 microfarad 25 volt 2 numbers each. Capacitor 2.2 microfarad by 250 volt 1. Relay NC or NO 6 volt 1. Transformer 240 volt by 7.50 volt 2 ampere 1. Inverter transformer iron core laminated SWG 25 turns primary and 36 SWG 285 turns secondary 1. Fuse 2.5 ampere 0.5 ampere 1 each. SP switches toggle 6 volt 2. Let us take a look at the preparations for assembling circuits for the battery charger and inverter. In this exercise, our first task is to assemble the battery charging circuit. Make sure you have all the necessary components for your battery charging circuit. Typically, you will need components such as resistors, capacitors, diodes, voltage regulators, and possibly an integrated circuit (IC) for more advanced charging circuits. It is crucial to know the specifications of the battery you intend to charge. This includes the battery type, example, lithium ion, lead acid, nominal voltage, maximum charging current, and any special requirements or considerations. Adhering to the battery manufacturer's guidelines is essential for safe and efficient charging. Plan and design your battery charging circuit on paper or using circuit design software. Consider the charging method you want to use, such as constant voltage or constant current. Select the appropriate circuit topology accordingly. Select suitable PCB, wired PCB, and other components. Check all components, that is, transformer relays, battery for their good condition. Construct the transformers, relays, and other components on PCB. Connect the charger transformer X1 to the auto transformer X2. Connect the secondary of the charger transformer X1 to the full wave bridge rectifier, which supplies reflected voltage to the battery under charge through ammeter, voltmeter and potentiometer. Reset switch S4 is used to reset the charger when any fault occurs and the charger is cut off. The switch S1 for on or off. Connect the on or off switch S1 to the input of the AC main supply. Connect the diodes, neon lamps, fuses, capacitor, resistor, buzzer, low voltage lamp in the correct position as in the circuit. Solder all PCB connections neatly and clean the PCB without making any short circuit. Set the auto transformer X2 in zero level position before charging the battery. Keep the switches S1, S2 and S5 in an open position. Connect the battery to the charger output terminal, positive terminal to the battery positive pole and negative terminal to the battery negative pole, and close the switch S3. Check the readings in voltmeter, which is connected through diode D9 and switch S3. Close the main on-off switch S1 by keeping the zero position of an auto transformer X2, and neon lamp N1 and lamp L1 will indicate on. Vary the setting of the audio transformer slowly from zero position until the voltmeter shows the reading nearer to the voltage of battery to be charged. Switch on the charging switch S2 and increase the voltage by varying the auto transformer till the required charging current, 5 ampere, is displayed by the ammeter. Leave the charger on to charge the battery to the required level. Switch off the buzzer by the switch S5. The error indicator neon lamp N2 and the buzzer stays on till the charger is reset. Press the reset switch S4 only if the process continues once again. Ensure that the circuit components are appropriately sized to handle the charging parameters. Ensure the safety features such as overcurrent or overvoltage protection are included. Task 2. Construct inverter circuit. Calculate the power consumption of the light you intend to power with the inverter. This will help you select the appropriate components for your circuit. Trace the circuit diagram. Identify each component of the circuit. Solder the components on PCB for making inverter circuits. Mark the inverter circuit board with charging circuit. Solder the components onto the PCB following the circuit diagram. Be careful to observe proper polarity for diodes and capacitors. Mount the power transistors onto the heat sinks and connect them to the PCB. Test the emergency light after connecting fluorescent tube light. Power up the circuit and test its functionality. Check the indicating LED, red and green, functioning correctly. Now remove the tube light and make the terminals free. Connect the terminals of mains to the supply and switch on. Check the corresponding LEDs are glowing and measure the output voltage. Connect the inverter circuit with supply. Disconnect the main AC supply and test the output of inverter by connecting load and note down the performance. Use a multimeter and an oscilloscope to measure voltages, currents and waveforms. Check the backup time of the inverter and verify the same with manufacturer's manual. Check for any issues such as excessive heat or abnormal behavior and troubleshoot accordingly.
Recap. Let us just recap what you have learned so far. Draw the circuit diagram as per the specification. Assemble the battery charging circuit wired on PCB. Do the testing of the circuit wired on PCB. Construct the inverter for the given specifications. Do the load testing for the inverter. I hope you all understand how to assemble a battery charger and inverter circuits. Let us meet again in the next session. Thank you students and bye.